why is the focal length over there? Why is this the focal length? Why is the focal point over here and not further out or closer? What about this lens will dictate where the light coming in parallel to the principal axis and parallel to one another will just come into a focus. What's up? Why is it there? And that is what that formula is about. It tells you that what this length is going to be, and it's written, I think, something like this, right? And then what you have in that expression is that n is the index of refraction of the glass or plastic or whatever that the lens is made of, right? The transparent lens, right? So that's the index of refraction of the lens. Outside of that, you have air. And the index of refraction of that is roughly 1, right? 1.000 something, right? So what you have in here is the difference between these two indices of refraction. So I think you have an n-1 factor there, right? And then you have something that depends on the curvature of the front surface of the lens, where the light hits it, right? So what is the curvature of that front surface? So it's like this, right? So the center of curvature of that might be, it might be here, for example. So then this is R1. It has to do with how curved that front surface is. So that goes over here. And then it also depends on the curvature of the back surface of the lens. It depends on how curved this is. And that one might have a radius of curvature R2. And in this case, this is where I don't remember. There's a plus or a minus sign in here. I want to say it's plus, but I'm not sure.
That's minus.
But hold on. It's minus in the book?
I think so, yeah.
For the following reason then. Then that means that this is good. In the textbook, the lens that they drew was like this and like that. So this is the lens. So notice that the second curvature, right, is opposite. This one. And that changes that sign to a minus. So in the textbook, then that's the front surface. You think of light coming in from the left, right? So that's R1. But in the textbook, the picture that they included, and I have to see it to double check, if it's like this, right, then this is the second surface, and the radius of curvature of that is like, is like that. So this one, for example, is curved like that, and this one is curved like that, same way, right? So they're both plus. Well, the formula here should be then 1 over f n-1, 1 over r1 minus 1 over r2. In this case, because the curvature of the back surface of the lens is opposite to this one. Is that the picture that they have in the book?
Yes.
Yes. So, and this is what they have in the book?
Yes.
Good. So if the lens is cut like that, then this is the formula. If it is cut like this, then this is the formula. So because the curvature of this back surface is opposite to the curvature of this one, it flips the sign. You could have a lens, for example, by the way, this is called biconvex. That's it, it's like convex in both of them. I don't know what they call this one, but sometimes you have a lens that's cut like this. So this is the glass here, right? And so in this case, what will be the focal length of this? 1 over f equals n minus, if you have air over here, that will be n-1, and then 1 over, and then plus 1 over something over here, right? Now, what is the radius of curvature of this one? Okay, so that's the first lens, right? So that'll be R1. But what is the radius of curvature of a flat surface? Infinity. So for this one, it's like, oh, this one goes, R2 goes to infinity. So this is 1 over R2, which is infinity, so this goes to 0. So the focal length is just determined by the curvature of the first one. So then you have this. Yes. And this is called plano convex. So it's convex and planar, like a plane, plano convex. Right? So I guess I got lucky today where I was able to write this correctly. The thing that I'm always like, I don't remember very well, is the plus sign or minus sign over here. So now that I'm telling you about it, I think I'll just think of this, right? Like curve like that on both sides, and then it'll be a positive. Then that'll be a way of doing it. So no, you don't have to know the formula. It's a formula that you look up. The other thing, the reason why one of the purposes of assigning one of those homework problems, which I think is the one that you're referring to, is the following. Suppose I take a lens and I give you a lens and I ask you, where's the focal length? Like the one you use in the lab, right? I never said you have to position it like this with this surface facing the light coming in. It doesn't matter. So you in one of the problems, let's say you have a lens like this or like this. I don't remember what the problem is, but the idea is that suppose you place it like this and you have light coming in like this, right? And there's a focal point somewhere and you figure out the focal length. Suppose you take this lens and you flip it around and then you send the light, the focal length is in the same spot. So it doesn't matter which phase the light hits first. Right? So that was one of the purposes of that. It doesn't matter how which side of the lens the light hits first. It doesn't matter.
Okay. And then I had another, if you could pull up the solutions. I was just confused on one. Huh? No, for this again. Like, he did it was like, it was in that form, but it was like minus negative R2.
That's chapter 34?
Yes.
Oh, sorry. It was supposed to be the solutions, right? Not the chapter.
And then for 25, I think.
Did you say 25?
Yeah. It was something small, but it was kind of like, it threw me off.
But this is the one that I'm talking about.
Yeah, I meant, so the part that confused me is why is the radius 2 negative 13 centimeters? Is it because it's going out to the right?
Because in this, right, so R1 is the radius of curvature of the front surface and R2 is the radius of curvature of the second one. So that's this formula, is negative.
No, but see, it's minus 1 over negative 13 centimeters. That's what I was confused about. How is the R2?
So this is the formula, right?
Yeah.
And then if it's curved like this, then it's positive, and if it's curved like that, then it's negative. Then you put in negative. Because notice, this negative and this negative makes it positive. But that's just consistent with this, because that is this positive. That's how this becomes a positive.
I see. That makes sense.
Yeah. In other words, I guess I just told you the result is this, or the result is this, whereas over there you kind of, it's opposite of what it is in the book, so I gotta put an extra minus sign, and a minus sign over here multiplied by a minus sign will make it a plus. That's that.
Okay. Yeah, I was just like, how is the radius? That's what I was confused about. I was like, how can a length be negative? That's why I was like lost. Thank you.
Ale?
Problem 69.
16?
69.
69.
It's the one where they gave you get the length and then for both sides and then you get the derivative. And then after you get the derivative,
This one?
you change from OM to MO to OM and that switches to negative, but then the negatives can't go out. I understand that part, but I kind of don't just understand like how, but why there's two negatives that cancel.
I'll say I have to read the book because the chronicles I don't remember it.
If I remember, it's basically asking.
Somebody's running away from the mirror, right?
Yeah, and it's asking how
So here's the
far
object.
are you running away from the image, basically.
Oh,
And
so it's the velocity of view relative to the image.
yeah, but it's easy to think of it like, well, you and the image are running away from each other.
Yeah.
So it's
Yeah.
the speed you're running plus the speed of the images. Running.
Which is the same as yours in the other direction, so it's
Yeah.
like,
So you're both running away from each other.
I thought about it logically like that too, but then I didn't know for this one.
but did I get the right answer mathematically?
Yeah, the thing is mathematically.
So, the question is, we want to know, I guess I phrased it over there, we want to know the velocity of the image relative to the object, right? So, I think I mentioned this last time with relative velocity, like the velocity of, what was it, the baseball relative to the ground is equal to, then you write B first, and then G is the last one, and then whatever you write here has to be the one that you write over there. So that was the truck. Baseball relative to the truck was the velocity of the truck relative to the ground, right? So what I want to be here is the velocity of the image relative to the object, right? Right? The velocity of the image relative to the object. So notice the image, the I goes first, and then the O goes last, right? Now what am I missing is the mirror.
And
Right, so the mass of the mirror, not the mass of the mirror, the mirror. Right? So this is the velocity of the image relative to the mirror, and this is the velocity of the mirror relative to the object. But when you interchange two subscripts, you multiply by -1. Is that the question?
yeah, and I think that's where I got mixed up.
Okay, so let me give you an example. I'm driving a car, and there's a building ahead. So I'm driving towards the building, right? So suppose I'm driving at 60 miles an hour. So what is the velocity of Arnold relative to the building? 60 miles an hour to the right. Now, if I ask you, well, suppose I'm with you. Hey, Alan, what's up? Or we're going towards the building at 60 miles an hour, and you might say, slow down, man, you're going too fast. You're gonna get a ticket for speeding because the speed limit here is 40 miles an hour. But then I can say also, you know what? You're not going anywhere. You're always next to me. And I think we're not really going anywhere. I think we're not going towards the building. I think it's the building coming to us. So if I ask you, what is the velocity as I drive at 60 miles an hour towards the building? What is the velocity of the building relative to me? So now I want the velocity of the building relative to Arnold. Notice I switch the indices, right? So how fast will the building be approaching me relative to me?
Maybe the 60 miles.
60 miles an hour the other way. So when you switch, if I say the velocity of Robert relative to Julia, that's the negative of the velocity of Julia relative to Robert. If you switch the indices, then you put a minus sign. That's the physics behind that. So maybe I did a step over there where I switched the indices, because notice over here, I want the velocity of the mirror relative to the object. But I probably know the velocity of the object relative to the mirror, so I switch the indices and then I gotta put a minus sign. That's what I'm kind of anticipating based on your question. And so I wrote, oh, here it is. But the velocity of the mirror relative to the object is the negative of the velocity of the object relative to the mirror. So that it's that issue. It's Arnold, the building, it's the same thing. I switch the indices, right? So then I gotta put a minus sign. So therefore, the velocity of the image relative to the mirror stays the same, because I probably know the velocity of the object relative to the mirror, not the velocity of the mirror relative to the object. But if I know the velocity of, I'm talking too fast.
No, I'm fine. Yeah.
Yeah?
Yeah.
So I switch the indices, so I gotta put a minus sign. Right? But the velocity of the object relative to the mirror is 3.6 meters per second to the left. Right? So here's the mirror, here's the object is running away. I just introduced, reference to the right is the x-axis, I had to the left, minus I hat. So the velocity of the object relative to the mirror, the magnitude of that vector is 3.6 meters per second to the left. But then the velocity, what is the velocity of the image relative to the mirror? Well, the image is going this way, and it would have to be going at 3.6 meters per second I hat to the right. You can just write that directly. And so, and then you do the.
Can you just done like 3.6 meters per second plus 3.6 meters per second?
Yeah. Like, one of you said, yeah, or I think you said, I wanted to think of it logically. Yeah, that's the logic. But this is how you prove it, that logic is good. But yes, your image is moving away from the mirror just as fast as you are moving away from the mirror. As the object is moving from the image, so right.
So it should be 2 times your velocity.
Exactly. It's like two cars going in opposite directions at 30 miles an hour, 30 miles an hour. So what is the velocity of one car relative to the other one? 60 miles an hour. You can just say it, right? I mean, because yeah, if you can say, well, that's obvious to me, but then prove that to me. So it's kind of what I did over here. But yes, that's the logic. Any other questions? Okay, so Cosé is here, and Carissa is also here, right? Okay. So back to the special theory of relativity. I mean, once you start thinking about this, it's very, very counterintuitive.